Let's test our skills at evaluating expressions with square roots. To keep it simple, we're going to assume that all square root values in these problems are positive. Let's test to see how well we can do with square roots in evaluating expressions. To make it simple, let's assume that all of our roots are going to be positive. Well, the first thing we have to do is evaluate our numerator. So that means doing 98 divided by 2. 98 divided by 2 gives me 49, so now I can take the square root of 49. The square root of 49 is 7, which means for my final value, I simply need to do 7 divided by 7, which gives me 1. Let's test to see how well we can evaluate expressions that include square roots. For simplicity's sake, we're going to assume that all of our roots are positive. Well, first we need to simplify our numerator and denominator, and we'll start by taking the square root of 64 and 4. The square root of 64 is 8, and the square root of 4 is 2. Now we can simplify our numerator and denominator still by dividing. 16 divided by 8 is 2, and 16 divided by 2 is 8. Now we could leave our answer as 2/8, but rather we're simply going to take that fraction and simplify it to lowest terms, which gives us our final answer of 1/4. As we simplify this expression, we're going to assume that all of our roots are positive. Here we have the square root of 12 divided by 1/3. Well, since we involve 1/3 in the denominator, we're going to go ahead and rewrite that as a fraction division problem, 12 divided by 1/3. Well, now I can make 12 into a fraction and multiply by the reciprocal, so I have 12 over 1 times 3 over 1, which gives me 36 over 1, which simplifies to just 36. When I take the square root of 36, that tells me my final value is going to be 6. As we work to simplify this expression, let's assume that all roots are positive. The first thing we have to do is simplify the numerator by working with our exponents. 6 squared is going to be 36, and 5 to the 0 power is going to be 1. From there, we can continue to simplify our numerator by subtracting. 36 minus 1 is 35, and then we can divide. 35 divided by 5 gives me 7. 7 is both prime and not a perfect square, so we're simply going to leave our value as the square root of 7. Let's use what we know about square roots to simplify this expression. We're also going to assume that all of our roots are positive roots. The first thing we need to do is simplify the denominator by taking the square root of 25. Square root of 25 is 5, so now we have 100 divided by 5. 100 divided by 5 gives us 20. The square root of 20 isn't a perfect square, but we can simplify it. Square root of 20 can be broken down into 4 times 5. The square root of 4 is a perfect square, which is 2, so in simplest form, our answer is going to be 2 times the square root of 5.